Another thing we're going to look at is what's called the base angle theorem. And when we're looking at the base angle theorem, we're looking at isosceles triangles. So given that triangle BAT is isosceles with base TB, an isosceles triangle means that the legs are congruent. So we have those two legs are congruent. It would also mean that those base angles are congruent. So for this first one here, we'll set 3 times x plus 2 equal to 24. And then we have to distribute the 3 to solve for x. Subtract my 6. And I'll get x equals 6. So the base angle theorem in words is saying that if two sides of a triangle are congruent, then the angles opposite them are congruent. And then the converse of that statement is also true. So what we're saying is, if I give you those two sides are congruent, then you can tell me the angles opposite them are congruent. Or the converse of that statement, if I tell you that base angles are congruent, then you could tell me that the sides opposite would be congruent. So applying that in some examples here. So for this first one, we got a lot going on in this triangle. So for this first one here, I'm going to look at the big triangle first. The big triangle first has all three of those angles are the same. And applying that concept that we just talked about, if all the angles are the same, that means all the sides are the same. Which means all three of these big sides have to be 46. Which means I can now find y, because I can take 16 away. It's 46 minus 16, so y is equal to 30. Now, in order to find x, I need to remember that when we say all of the angles are the same, that means all of them are 60 degrees. So up here is 60 degrees. So now I'm only going to look at this little triangle up here with x. Because this angle is 80, its supplement is 100. So now inside that little orange triangle here, I have x, 60, and 100, which means x has to be equal to 20. Number 2. First off, again, looking at this triangle, which is equiangular, which really means it's also equilateral. So all the sides are the same. It also means that all of the angles are 60 degrees. So again, applying the straight angle, the supplement, that would mean that that angle is 120. So I'm going to then look at, I'll highlight this one, the blue triangle. When I look at this blue triangle here, I have two sides that are congruent. Using that base angle theorem, that means that the angles opposite are the same. So if that top one is x, that means this one down here also has to be x. Well, I now have all three angles in that in the blue triangle. They are 120 plus x, and all angles must equal 180. So 2x equals 60, which means x equals 30. Now looking at the sides, again, looking at the fact that I've marked sides congruent. That side is congruent to that side, which means it is 20. Well, that means all three of those sides are equal, so 5y is also equal to 20, which means y equals 4. Explain why triangle ABC is isosceles. So we got to look at ABC, but we got to get there first. So let's look at the triangle on the other side because I have marks there. So I have these tick marks for the sides. That means the angles opposite are congruent. So I know that angle E is 70. I now have all three angles in the triangle, or I can find the third angle. Subtracting 70 and 70 from 180, I know that that angle is 40. Using the vertical angles, I can get this angle is also 40. Now I can find angle A, 70, and same concept on the other side. If two angles are congruent, then the sides opposite them are congruent, which means that the triangle is isosceles because of the base angle theorem. If angles are congruent, then sides are congruent. Can an isosceles triangle be an obtuse triangle? So an isosceles triangle means that we have two sides congruent. And an obtuse triangle means that you must have one angle greater than 180 degrees. So can you create a triangle that has an angle not 180, greater than 90 and less than 180? Can you create a triangle that has an angle greater than 90 degrees with two sides congruent? We can come up with many examples. I'll just give you one. 100, which means that the other two angles must be congruent, which makes 40 and 40, which makes the sides congruent. So the answer is yes, that can definitely be done. There are many, many examples. And that will conclude our notes for 5.2 and 5.4.